Greetings, M squared here. Today we're going to simplify radicals. Now when you simplify radicals you have to remember three rules. And these are the three rules. Most of the time you just deal with this perfect squares rule, but every once in a while you have to worry about fractions. So these two pertain to fractions. You can't have any fractions under the radical, and you can't have rats in the basement. Rats is short for radicals. So like this one has a radical in the basement or in the denominator. This one has a fraction. And these two we're going to use just the first rule. So if there aren't any fractions, you know that it's this rule that you're dealing with. And then otherwise, sometimes you have to use all three rules. So let's start with this one. It's a good idea to have a perfect squared list, like to just, you can make one on your paper. You know the side of your paper, you can just say what's 2 squared, what's 3 squared, what's 4 squared, what's 5 squared. You know, having that list there so that you can see what numbers you're looking for is really valuable. So I'll just write a couple down. So when I'm looking at 125, I need to see which of the numbers on my perfect squared list actually goes into 125. And I know that 25 does. 25 goes into 125 5 times. So when I rewrite this, I'm going to say 25 times 5. Now that's still 125. I'm not changing the value of it, I'm changing it how it looks. Because in order to get the perfect squares out, you've got to know what they are. The same thing goes with x to the 5th. When you're doing square roots, our index is 2, then we want to split this up into something that's even, an exponent that's even. So I'm going to change my x to the 5th to x to the 4th times x. And then here with my y's, I'm going to do the same thing. I'm going to change that to y squared times y. Remember, that's like a 1 up there. You can put a 1 there if you want. So why that's important is because all those things that are perfect squares, I'm going to just rewrite it a little bit differently. You don't have to do this step. I just kind of want to show you what's going on. All the things that I know I can take the square root of, I'm putting out here. The things I know I can't, I'm putting it here. So 25, the square root of 25 is 5. The square root of x to the 4th, there's 4 x's there. That's what x to the 4th means. X times x times x times x. When my index is 2, every set of 2 that I have becomes 1 on the outside. So I have 2 sets of 2, so I know it's x squared. I only have 2 y's, so I know only 1 jumps out. The square root of y squared is y, the square root of x to the 4th is x squared. And then these are the things I can't take the square root of, so those stay inside. So this is my simplified version of this. Notice I have a little 4 as an index. That means I can't use my squared list. I need to use my 4th list. And 4th one, 2 times 2 is 4 times 2 is 8 times 2 is 16. And that's the one we're going to use for this one, because 32 is 16 times 2. So to the 4th root, I know it's 16 times 2. I don't have 4 a's, so I know all of my a's are going to stay in, but I have more than 4 b's. That should go over like that. So I'm going to change my b's, my b to the 5th. Whoops, I didn't really need to do any more of that. I'm going to make that a b. My b to the 5th is going to be changed to b to the 4th times b, because I need 4 b's now to get 1 out, because this index tells me how many I need inside to get 1 to come on the outside. So I'm going to change that into the things I can take the 4th root of times the things I can't take the 4th root of. So the 4th root of 16 is 2. The 4th root of b to the 4th. Another thing people do is they take this and divide it by the index if it's divisible, and that's why we put the 4 there, because we knew it was divisible, so that just becomes a b. And then I'm left with this. Now keep in mind that little index is really important. If you forget that, it totally changes the problem and you'll get it wrong. So make sure you always write that index unless it's a 2. And even if it is a 2, you could write it if you want to get in the habit of doing it. Okay, so that was our first rule. Now we're going on to our second rule. Hopefully you did this in Algebra 1. This is the Algebra 2 version, so if you didn't do it in Algebra 1, this might kind of seem crazy. I'm breaking the fraction rule. So the first thing I do is get rid of the fraction, and by doing that, well, how I do that is I just write a square root expression over a square root expression. Now I don't have a fraction under the square root. Now I'm breaking this rule. I have a radical in the denominator. So to get rid of that rule, when it's a monomial, meaning one term, there's not like a plus something else or a minus something else, I just multiply this fraction by the number 1. Notice that's a funny looking 1, but I do that to get rid of this. So, because 6 times 6, if there's 2 6's and 2 y's, then the square root of 6y times the square root of 6y is just 6y. Because I have 2 of them. Remember I talked about the two, if it has a set of 2, 1 comes out. Then over here, 3 times 6 is 18, x cubed times y. So now I am breaking this rule. So this one we're actually going through all 3 rules. And why I'm breaking that rule is because this has something perfect on it. If we look at our squares list, it has a 9. 18 is 9 times 2. X cubed is x squared times x, and then times y. So I can take the square root of this, which is 3. I can't take the square root of that. I can take the square root of this, which is x. And then what's left is the stuff that I didn't cross off. And notice now I'm not breaking any of these rules, but it's not simplified because a 3 and a 6 are still reducible. So 3 goes into there once and 3 goes into there twice. So my final answer is x square root of 2x minus y, I said minus, x times the square root of 2xy over 2y. And I cannot cancel here. Be really careful about that. This 2 is inside the radical. It's the square root of 2, which is like 1.4. It's not 2. And this is the square root of y, not y. So some people want to cancel that. Don't do it. You can only cancel things on the outsides or the insides. Okay, now this is a little trickier because you have a cube root that you're trying to get rid of. Now, one thing that you can do is if you have cube root of something over cube root of something, you can cancel what's inside. So now I have the cube root of 4y over the cube root of x squared, and that just makes it a little bit easier to deal with. So if I can cancel first, I usually try to. Not always, because sometimes it's easier not to. That just takes time to figure out. So I've got to get rid of this. Notice that it's a cube root, so that means I need 3 things to get 1 on the outside. How many do I have? This tells me. So how many more do I need? Well, if I have 2, I need 1 more. That's the tricky part, because over here we multiplied by the same exact thing because we had a square root and we know we wanted to get rid of it. So we needed 2 of each thing. But when we need 3 of each thing, we've got to figure out how to get 3 of that thing. So when I multiply the cube root of x squared times the cube root of x, I get the cube root of x cubed, or just x. And then on top, I'm going to multiply all those things together and I get a 4xy. And that is my final expression. So don't get discouraged with this. I know this can be tricky and challenging, but just go step by step and make sure you're using your rules, and you'll get it. Good luck. M squared, sign out.